Hello friends, in this lecture we are going to start a new module in Catia that are called dress up features. So dress up features are used to edit the 3D geometries. Now if I go to insert option, click on this insert and then go to dress up features. We can find edge fillet, variable fillet, chordal fillet, etc. And then we have chamfer, draft and some more options in draft, shell, thickness, thread, etc. So we are going to cover all these options in this module. Right now we can see there is no toolbar highlighting for the dress up features. So to insert that toolbar, I go to this view option, click on toolbars and then go to dress up feature. Right now we can see there is no check on this. So make a check on this and now we can see dress up feature toolbar is highlighting. So just place this, hold down the left click and drag it. So just place it where we want. And then right now we can see commands are hidden. So these commands will be visible when we will create some geometry. So to understand this, I go to this file, click on this open and then select this file, that is edge fillet. Select this file and click on open. Drag this and then ground view. So in this file we can see we have created some bed and pocket. And now we are going to insert fillet into this. So I go to this fillet option, click on this arrow. We have edge fillet, variable radius fillet, chordal fillet, etc. So I'm selecting edge fillet. Now in this window, first let's click on this lash option. It is asking us to select an edge. So it is asking object to fillet. And then we have radius of fillet and then selection mode. So if I click on this arrow, we have tangency, minimal, intersection or intersection with selected feature. So let's select this minimal option for first. And then I will select this inside edge. So select this edge, click on preview and then click OK. And now we can see a fillet has been inserted. So this fillet is not a proper fillet. So to create a better fillet, I go to this edge fillet, make a right click and then clear selection. And then in the selection window, I click on tangency. And then I will select this complete edge. Select this edge, insert the value of radius and then click OK. And now we can see a fillet has been inserted. So let's have a better view of this. And then I go to edge fillet once again. So we can select edge one by one. So let's rotate it. And then we need to select the edges. So I can select multiple edges at a single time. Select this edge, multiple edges and then click on preview and click OK. Now we can see fillet has been inserted. So let's explore some more options in the fillet. I go to fillet option. This time I will select a face. So select this top face and then click on this more option. In this more option, the first option is edge to keep. So right now I'm not going to select this option. And the second option we can see is limiting element. So to understand this, let's drag it and then click on this window for limiting element and then I will select this datum plane. Now it is highlighting the arrow. So this arrow is highlighting the direction. I reverse this direction and click on preview and click OK. So it is not creating a proper fillet. Once again, let's make some more changes into this. Let's try to reverse the direction. Click on preview. OK, and then click OK. Now what happened is that the fillet has been created with respect to this direction. So the fillet has been created onto all these left elements. So in this way we can create the fillet. So I select this edge fillet, right click and then delete. So I'm going to delete all the edge fillet that I had created. And then there are some more options in the fillet. So let's delete this. Click on delete. And then I go to fillet once again. Edge fillet. I select this edge. And let's increase the value of this radius. So I will take the value of the radius. Let's say this value I take 40. And click on preview. So now it is showing an error that this value is too large. So we can see in this preview, this fillet is going outside the geometry. So in this types of situation, we have an option. So I can click OK and click on edges to keep. So click on this option and then I will select this edge. So this is the external edge up to which we want to create the fillet. So select this edge and click on preview and click OK. So now this time the fillet has been created up to this edge. So once again go to fillet option. Click on this lash. Okay, if we want to insert a fillet of some variable radius. So for this we have some different options. So click on this cancel and then I go to variable radius fillet. Click on this and then we need to select the edge. So let's say I select this edge, insert some different value of radius. So let's say initially I will take value 5, click on preview. Okay, so now we can see we have two options of point. So let's zoom in. So we have first point and that is the end point. So the value is highlighting 5. So zoom in the better way like this. So go to these points and make a double click on this. Now we can insert some different value. Let's say I select this value 10 and then click OK. Click preview and now we can see we have a fillet of variable radius. Now we can also insert different point into this. Click on this point option and then we can select any point. Click on this point, click close. To change the value of the radius, make a double click on this value. So this time we can select this value 12, click OK and click OK. And now we can see this fillet is of variable radius. So in this way we can insert the fillet. Hello friends, in this lecture we will know about some more options in the fillet. So I go to file option and click on open. And we will start with this caudal fillet. So click on this caudal fillet and click on open. And then ground and drag this. So caudal fillet is one more option to insert the variable fillet. So let's go to this option. I click on this arrow and then we can find this option of caudal fillet. So I click on this caudal fillet. So in the caudal fillet, the parameter we can see is the caudal length. So instead of radius, we use the value of caudal length. So let's rotate this model and then we need to select the edge. So I select this edge and then click on preview. And now we can see the preview of a fillet. So let's zoom in here. So the value of fillet is very less. So let's increase this. Let's say I take this value 50 and then click OK. Now we can see we have a fillet. And now we are going to make some more changes into this. So make a double click on this edge fillet and then go to point option. In this point option, select this plane. Click on this variable plane. And now we can see we have inserted a third point. In this point element, we can see we have a point number 3. So I can click close and then we can define the caudal length for this point. So take the mouse into this and make a double click on this. So let's give some different value to this. I give this 20 and click on OK. And then click OK. And now we can see we have a variable fillet. So the value of fillet is defining by a caudal length. So once again I go to file option and click on open. So next type of fillet we have is the face fillet. So select this face fillet and click on open. Once again drag this and ground view. Let's zoom in. Okay, drag it and then zoom in. Now we can create fillet with respect to two faces. So to create this type of fillet, I go to fillet option and click on face fillet. And then we need to select the faces to fillet. So select this first face and then select this second face. Insert the value of radius and click on OK. And now we can see these two faces are fillet by a radius of 30. So in this way we insert the fillet radius. So once again I go to file option and click on open. And the next type of fillet I want to talk about is fillet with respect to curve. So select this option, fillet this curve and click on open. And then zoom out, ground view and drag this. So in this type of option, we can create fillet with respect to a chord or any spline. So in this, the parameter of fillet radius is not defined by the radius. So to understand this, I go to face fillet and then let's zoom in here, rotate this. We need to select two faces. So these two faces should adjacent to each other so that we have an edge to create the fillet. Select this top face and select the side face. And now we can see face 2 fillet, two elements are selected. On the right side, go to hold curve. Click on this selection window and click on hold curve. So the radius of this fillet is defined by this hold curve. So select this top curve as a hold curve. In the spine, click on the second curve and click on preview and click OK. And now we can see we have inserted a fillet. So this fillet is with respect to this top curve, that is hold curve. So in this lecture, we will know how to insert chamfer in our 3D geometries. So we can find this chamfer in the dress up toolbar, that is chamfer. So right now it is not highlighting. So for this first we will need to create a 3D geometry. So I go to this pad tool, click on this pad. In this I take this XY plane, that is top plane. So click on this sketch and select this plane. Draw a rectangle of any dimension and then click on exit workbench. Give it some height. So let's say I take this value 2 and click on preview. Okay, we can increase this value to 4 and click OK. And now we are going to insert chamfer into this. So click on this chamfer tool. So in this chamfer, we can see the first option that is highlighting is the mode. So click on this arrow, we have length and angle, length 1, length 2, chordal length and then height and angle. So I'm going to start with this length and length. So click on this option of length and length. And now we can see we have length 1 and length 2. So to insert the chamfer, we need to select the object. And then we need to select the edge. So click on this edge. And let's zoom in here. Now we can see the preview of a chamfer. So in the chamfer, an edge is replaced by two edges. So let's click on preview. And then click OK. And now we can see we have a chamfer. So if I rotate this to the front view, click on this front view, we can have a better preview of this chamfer. So the value of this chamfer is calculated from this corner point. So to have a better view of this, once again, I go to chamfer tool. So we need to select this edge. So let's rotate this object. And then select this edge. And then click on front view. Let's zoom in here. Change the values. So I take this value 2 and then I take this value 1. Click on preview. So if I select this option of symmetry extend, it will create a symmetric chamfer. It means similar value on the both sides. So click on this preview and click OK. Now we can see this chamfer is higher on this length 2 and lower on the length 1. So in this way we can create the chamfer. Now we can also create chamfer with some more parameters. So let's go to isometric view, zoom out, and then go to chamfer tool. Click on this option of length 1 and angle. So in this we can create chamfer with respect to length and angle. So let's click here. So click on this edge. So select any edge and then try to rotate this. We can select multiple edges at a single time. So right now we can see 2 elements are selected. Okay, click on fit view. Rotate this and then zoom in. So if you want to make some more changes into this selection, click on this bag icon and then we can select the edges. We can remove them or replace them. So let's remove it. Now we can see we can define this chamfer with this angle and the value of length. Click close and click on preview. Click OK. And then once again I go to chamfer tool. Click on this option of chordal and length. So in this time the length will be taken as a chordal length. So click on this option and then zoom in. Once again let's zoom in here. I want to show this value. So the length of the chamfer will now be measured from this point to this point, and that is the angle of chamfer. So click on preview and click OK. So in this way we can insert the chordal chamfer. So last type of chamfer we have is the height and angle. So select this chamfer and then we need to select an edge. So let's rotate this model first and click on this edge and then zoom in. And now we can see this time the value is measured from this point up to this midpoint of the opposite line. So that is the value of height. Click OK for this chamfer. And in this way we can create multiple types of chamfer. Hello friends, in this lecture we will know about hole feature in Catia. So basically we will know how to create hole in the geometry. So we can find this hole command in this toolbar. So this is the hole. So right now we can see the hole command is not highlighting. So first of all we need to create some 3D geometry and then we can use this hole command. So before going to this hole, we need to understand about some different types of standard holes. So generally in Catia, we have different types of hole. These holes are blind holes, tapered hole, counterbore hole, countersink hole and counter drilled hole. So first of all, we will know about all these holes one by one. So in this example, we can see a blind hole. So a blind hole is basically a hole that is reamed, drilled or milled to a specified depth value without breaking through to the other side of the workpiece. So we can see in this example, we have a drill tool and we are creating a hole. It is called blind hole because it is not a through hole. So it is not crossing this object. And the second type of hole we have is the tapered hole. In the tapered hole, the hole diameter changes along the length. And we can see we have a hole. So its diameter is decreasing along the length. So the main dimension in the taper is taper angle. That is specified by this angle theta. And the next type of hole we have is the counterbore hole. So a counterbore hole is basically a cylindrical fillet hole that enlarge another coaxial hole. Now we can see in this example, we have a larger hole on the top and then on the bottom we have a smaller hole. So this is called a counterbore hole. So counterbore hole is typically used when a fastener such as socket head cap screw is required to sit flush. Similarly, the next type of hole we have is the countersink hole. So there is a difference between countersink and counterbore hole, that in the counterbore hole we have a rectangular profile on the top, while in the countersink hole we have a conical profile. Now we can see in the top the diameter is decreasing in a conical way. And the next type of hole we have is the counter drilled hole. So in counter drilled hole we have multiple holes of different depth at the same center. And we can see in this example we have two holes of different diameter, but these are of common center. So threads are basically used to fashion the geometry. So now in the threading we have some parameters such as diameter, that is major diameter, minor diameter and pitch diameter. So the value from this point up to this end point is called the pitch, and that is called the diameter. We can also understand this from this example. We have hole diameter and then thread depth. So up to this point, that is called thread depth, and this is complete value is called hole depth. And then we have hole support plane and thread diameter. So now we are going to create some hole in the Catia software. So first of all, we will create some 3D geometry. I go to pad option and then click on sketch. Select this top view. On this, I go to rectangle and draw a rectangle like this. Click on exit workbench and then click OK. So we can give it some height. I give this value 2 and then click OK. After that, we need to create the hole. So I go to hole tool, click on this hole option. And now first thing, it is asking us to select a plane or to select a sketch. So I select this top surface. Click on the surface. Onto the surface we can see the preview of a hole. So right now this hole is very large. So we need to set the parameters. And now in this hole dialog window, the first thing it is asking us to select the hole. So we have blind hole, up to next, up to last, up to plane or up to surface. So this point is specifying basically the value of its depth. So I want a hole up to blind. So blind means we can specify the value of depth. After that it is showing the diameter of hole. So let's say I want the diameter of hole 1. Click on preview. Now we can see a hole of diameter 1. So we can insert the depth value. So let's say I insert this value 1.5 because the depth of this plate is 2, and then click on preview. Okay, before this we can also specify the exact location of this hole. So for this I click on this positioning sketch. Onto this I click on this arrow, and now we need to specify the position. And now we can see this point is highlighting. So this point is basically the center of sketch. So we need to insert the constraint to specify a location for this. I go to constraint option, select this bottom line and select this point. Give it some dimension. So I insert this value 3.5, and we need to also insert this value up with respect to this vertical. So select this point and then specify a location. So I insert this value 8.5 and then click on exit workbench. So now we have properly defined the position of this hole. I can click OK. Hello friends, in this lecture we will continue with hole command. So in the previous lecture we have created a hole inside this plate. So now we are going to explore some of the more options in the hole command. So we have created a blind hole. So now I go to this hole option, make a double click on this hole, and now I want to make some more changes into this hole command. So the first option that is highlighting in this hole window is depth of the hole. So we already know about these references up to next, up to last, just like we have done in the pad option. So I'm not going to change this. So I'm selecting this as a blind hole. After that we have diameter and depth, and then we can specify the limit with respect to any reference or any offset value. So now we can see there is an option of bottom. Now we can select the profile which we want in the bottom. So click on this arrow, we can see flat and then V bottom. So if I select this V bottom, we can insert the parameter for this V bottom. So we can insert the value of angle. Right now we can see the value is set, that is 120 degree. So we can change this value according to our requirement. So right now I am selecting this as a flat bottom. After that, we can see there is an option of type. So click on this type option, and then in this we can change the type of hole. So I click on this arrow, we have simple hole, that is we call blind hole, then tapered, counter bore, countersink, and then counter drilled. So this time I will select this tapered hole. On the right side we can see the preview of a tapered hole. In the tapered hole we need to select the anchor point. So anchor point is the point that is highlighting with this red color. So we can select this enter point to the bottom or to the top. Okay, so now we can insert the angle value of the taper. So let's say I insert this value 10 degree and click on preview. So now this hole is tapered hole. Click OK. So I can zoom in onto this like this. And then if you want to make some more changes, I once again go to hole tool, make a double click, and then we can select, okay, then go to type, I can select counter bore. So click on this counter bore. On the right side we can see the preview of counter bore. Now we need to select the parameters. So in the parameter we have diameter and then depth. So diameter is 15, so let's take this value 2 and then click on preview. And now we can see we have a preview of a counter bore hole. So we need to select the depth of this bigger radius. So let's say this depth is 0.5. Click OK. And now we can see we have a preview of a counter bore hole. And then once again I go to hole option. So click on this hole and select this top face. And then I go to type. In the type we can select countersunk hole. Similarly we can insert the parameters for countersunk hole. So we can insert the parameters just like depth and angle, angle and diameter, and depth and diameter. So we can select any of these three options. Let's say this time I will select depth and angle. So angle is 10 degree and depth is 0.5. So I can click OK. So in this way we can insert the countersink hole. And the next type of hole is the counter drilled hole. So I make a double click on this hole. And then we can select this counter drilled hole. In the counter drilled hole we have diameter, depth value and angle. So you can change this value by yourself. After all these holes we have thread definition. So before this I will select the simple type of hole and then go to thread. In the thread option I make a check on this threaded. And then we have type of thread. So we can select dimension, support depth or up to plane. So I am selecting dimension. And then we have type of thread. So if I click on this arrow, we have metric, we have no standard, metric thin and metric thick. So if I select this no standard, we need to insert the parameters of the thread like thread diameter, hole diameter, thread depth and then pitch value. Also we have some standard value of the threads. So if I select this metric and click OK, we can see it is highlighting M8 into 1. So 8 is diameter and 1 value is the pitch value. So I click on arrow. So all these values are highlighting in the millimeters. So M10, we can select this M10 hole. Now we can see it is a very big hole. So we can select some lesser value and then we have metric thick plate and then we have metric thick pitch. So in this the value is highlighting M1.8 value. So I can select this M1. So M1 is representing the diameter of hole and then we can insert the value of thread depth and hole depth. So I can click OK and then in this way we can insert the threads into the hole. Hello friends, in this lecture we will know how to create draft in the geometry. So to create the draft, first of all we need to insert a geometry. So I go to file option and click on open, and from the project file click on this file that is draft 2. Select this file and click on open and then go to ground view and then drag this. Now in this draft geometry we can see we have created a pad. So first of all, we are going to insert draft into this pad. So I go to this draft option, click on this arrow, we can see multiple types of draft. We have draft angle, then draft reflect line, and then variable draft. So I am going to start with this draft angle. So click on this draft and then let's drag the mouse. So in the draft option, we can see we have two types of draft, constant and variable. So with the help of draft tool, we can insert inclination to any face. So to understand this, now we can set the value of angle. First of all, we need to select the face to draft. Let's say I select this top face and then we need to select the neutral element. So this element or this face will work as a reference. So let's click on this selection window. Now we can select any edge or any face. So I'm going to select this face as a reference face. Click on this face. And now we can see with respect to this face, we can provide the angle of inclination. So let's increase this value. Take this value 15 and then click on preview and click OK. Now from this view we can see the face has been inclined to an angle of 15 degree. So let's undo this, click on this undo and then once again go to draft tool and then this time I will select different faces to create a draft. So I select the side faces, so select multiple faces at a single time. So the faces that are selected are highlighting in this red color. So I am going to select all the faces like this. So I have selected all the faces which I want to create the draft, and then we need to select the reference edge. So click on this window and then click on this top face. So this top face will work as a pull direction. And then in the propagation we have smooth. So if we have any curvature feature, we can select this option of smooth. So right now it is none. And then insert this value of angle, that is 15 degree. Click on preview and click OK. Now we can see we have inserted draft in all the faces. So go to this model tree, click on this draft 1 option. So make a double click on this. In this draft, if I click on this option of more, we have one more option that is called define parting element. And then we have second option that is called limiting element. So we are going to learn about this limiting element. So click on this window, select this first plane and then select the second plane. So these arrows are highlighting the direction of limiting element. So click on this preview and click on OK. So we need to reverse the direction of this arrow. Just make a click on this direction. Now we can see, now it is showing the limiting element between these two planes. Click on OK. So now we can see the draft is created only between these two surfaces or these two planes. Okay, so that is the use of this limiting option. So one more feature in the draft tool is creating the variable draft. So I click on this draft, make a right click and click on delete and click OK. So I delete all the draft and then go to this draft tool. We can select this variable draft or we can select this variable draft from this top menu variable. So in this we can define different angle for different points. So let's rotate this and then we need to select the face. So I select this top face and then this side face as a neutral element. And now we can see draft value is highlighting at 2 points. So if I make a double click on this, I can insert this value 20, click OK. And then we can also select the draft for this point. So make a double click on this. So let's take this value 15 and click OK. So now we have two different values of the draft. So click on this preview and click OK. Now we can see in this geometry, we have a variable draft. So to make some more changes into this draft, make a double click on this and then go to this point option. So right now it is showing 2 points. So we can insert some more points into this. Just click on this bag icon and then it is showing the point. So we can make a right click on this and then click on create point. And then we can create this point by using the coordinate, or I can select any point inside this. So select any point and click OK. So now I have inserted one more point, click OK, and then I can insert some different value of the radius. So I can make a double click on this. Let's say I take this value 25 and click OK. Click OK once again. And now in this way I can create the variable draft. Hello friends, in this lecture we will know about rib feature. So rib feature is used to swapping a geometry with respect to a path. So we can find this rib command inside this toolbar. So this is rib. So to create this rib we need some sketch. So we have already created a sketch. So for this I go to this file, click on this open. In your project file you can find this rib. So click on this rib and click on open. So I go to view and then ground. Take this and drag this. And then in this rib profile we can see we have created a sketch. So this sketch is a rectangular profile. And then I want to sweep this rectangular profile along this path. So to create this sweep we need to use the rib tool. So to use the rib feature I click on this rib. So in this rib dialog window, first thing it is asking us to select a profile. We need to select the profile of which we want to create this rib. So I select this rectangle, click on this rectangle, and now we can see the profile sketch 2 is selected. And now we need to select a guide curve, or we can say the center curve. So I am selecting this curve as a center curve, click on this curve, and now we can see in this preview it is showing that this rectangle has been swept along this path. So I can click on this preview and click OK. So in this way we can use this rib feature. Now to make some more changes into this rib feature, I go to this rib, make a double click on this, and then in this dialog window we have profile control. In this profile control we have keep angle. So keep angle means it will keep the tangency, and then pulling direction. So we can create a rib along a direction by selecting this pulling direction. And the third option we have is the reference surface. After that we have some more option like merge rib end and then thick feature. So we can create a thick feature by this option. I make a check on this thick feature, and then we can provide a thickness. Now we can also provide the thickness with respect to a neutral fiber. So let's go to this profile to have a better view of this. I zoom in onto this. So let's zoom in and drag it. Now I can select this neutral fiber and it will create a thickness on the both directions. Now we can see in this preview we have thickness on outward and inward direction. So I make a uncheck on this neutral fiber, and then I select this option of reference surface. So we can create a rib which is along a surface. So click on this reference surface, and now we need to select the reference surface with respect to which it will create the rib. So I go to, so let's rotate this first, click on this fit view. I go to this model tree. We have created a surface that is called multi-section surface, but right now this surface is hidden. So go to this model tree, click on this, make a right click and click on this option of hide and show. Click on this, and now we can see the surface is visible. And then click on this preview and click OK. And now we can see the rib that is created is along with respect to the surface. So in this way we can create different types of ribs. Hello friends, in this lecture we will continue with 3D modeling and we will know about stiffeners. So stiffeners are used in the geometry to provide a support. Now to understand this stiffener command in more depth, I go to File, click on this Open, and then select this file stiffener 1 and click on Open. So let's drag this and then click on View and Ground. In this geometry, we have created two pads. We can see pad 1 and pad 2. So I click on Isometric. Now we can have a better view of this. And now we are going to insert stiffener into this. So before inserting the stiffeners, we need to create a sketch profile of the stiffener. So I go to Sketch option and then we have to select a plane. So let's say I will select this plane, that is, so I select this YZ plane. So select this plane and then normal view, click on this normal view. Okay, let's rotate this once again and then click on Fit View. And now we are going to create sketch onto this. To create this sketch, first of all we need to take the references. And to take the references, we need to project the elements. So click on this project 3D element and then click on this construction mode because we want those lines as a reference. So click on this construction, select this vertical edge, click on this and then select this edge. Click on this edge and click OK. Now both the edges are selected as a reference. So let's zoom in onto this. And then I go to line option, click on this line, select this first line, select the upper point of this reference and then select this bottom point. So let's pick this point like this. And then let's rotate this to a 3D view, isometric. Now we can see we have a profile of line. I don't want this line as a construction line. So select this line and make a click on this construction line. Make a uncheck on this. Now this line is not a construction line. And then click on Exit Workbench. Now I go to stiffener. So click on this stiffener. In this stiffener, we can see first of all we have two options. Mode from side and from top. So this stiffener is a side stiffener. So we have to select this from side and then we can insert thickness. So this is thickness 1 and thickness 2. And then we can make a uncheck on this neutral fiber. Make an uncheck on this and then we need to select the sketch. We can also create this sketch by clicking on this option, but we already have the sketch. So we can select this line, click on this line. Now we can see the profile of a stiffener. I click OK and now we can see we have a stiffener. So to make some more changes into the stiffener, I make a double click on this stiffener and then we can reverse the direction. So for the direction we have reverse direction option. Now we can see we have two directions. Now we can see one arrow is going to the rightward and one is going into the depth. So reverse the direction. Now it will create a stiffener on this left side. And then if I select this depth direction, click on this reverse direction. Now this stiffener is going outward. So it is an invalid body. So I can click OK and then reverse the direction to inward. We can provide the value of thickness from here. And then we can also provide the thickness equal in both directions. So I can make a click on this neutral fiber. Now the thickness is equal in both directions. Click on preview and click OK. So in this way we can insert the stiffeners. So if we want the stiffener of any more profile, so we just have to sketch it. I once again click on this sketch option. And this time let's say I will select this plane, that is ZX plane. So select this plane. And then for this we need to take some references. I click on this Fit View. And then Project Element, Construction Mode on. Select this vertical edge and this edge. Click OK. Now let's zoom in. And then I take the line command, make a double click. Select this edge, draw a line like this, and then once again a line from this edge up to this edge. So click on Fit View and then normal view. Press escape. And I don't want this line to be construction line, so select this line and this line. Turn off this construction. Similarly for this line, turn it off. And then exit workbench. And then we can rotate this. Let's rotate it. And then I go to stiffener, click on the stiffener option. And then we need to select the sketch profile, so it is selected, and click OK. So in this way we can insert stiffness of some different profile. After that we will learn how to create stiffener from the top. So for this I go to file option, click on this open. I select this file, that is stiffener 2. Select this file and click on open. And then I can drag this and then ground. Now in this we can see we have created a pad and then a pocket to remove the material. So in this we are going to add a stiffener. So first of all I go to sketch option, click on the sketch. I select this top surface as a reference, so select this top surface. And then we need to take the references, so click on fit view and then go to project 3D element. Construction mode is on. Select this edge and select this edge. Click OK. Now let's rotate it. Now we can see we have taken these two edges as a reference. Okay, so now we need to draw a line. So click on this line like this. And then I want a line from this edge. So we can rotate it to the normal view. Draw the line from this edge up to this edge. And then press escape. So I don't want this line as a construction line, so make a uncheck on this construction. So this line is created, and then click on exit workbench. And now I will add this line as a stiffener. So click on the stiffener. And then now since we can see this line is on the top, so we need to select the stiffener that is of top type. So click on from top. We are taking the value of thickness 1 and then select this line. So click on this line. And now we can see the stiffener is going in the downward direction. So click on preview and click OK. So in this way we have inserted a stiffener. So we have similar options to change its settings. Double click on the stiffener. Similarly we have neutral fiber. If we want the stiffener in both directions of equal thickness, you can insert a second thickness to this, make an uncheck on this, and then we can reverse the direction. And then I can click OK. So these are some different ways of inserting the stiffeners.